All right, guys, we're just going to look at 3 more examples in less than 5 minutes of how to determine whether data is linear, quadratic, or exponential just by looking at it. Okay, and well, yeah, just by looking at it, but doing some simple math, some adding, subtracting, multiplying, dividing. Okay, so this shouldn't be too hard. So in the last video we talked about how to do this. So let's go ahead and just look at these, and we'll see what we can do. So again, we want to make sure that x is a constant change. So -4 to -3 to -2 to -1 to 0. It's changing by 1 each time, increasing by 1. And so we can go ahead and we can look at the constant differences and the constant ratios. And so usually differences are easiest. So let's look at that first. So we'll go 18 minus 32. So 18 minus 32, so that some of you just won't believe me if I just tell you. So 18 minus 32 is -14. And then 8 minus 18, you should probably be able to do that in your head, -10. 2 minus 8 is -6. And 0 minus 2 is -2. Now those aren't the same, which means this is not linear. So now let's go on to the second difference. And so we'll look at the second row of differences. So -10 minus -14, which is 4. -6 minus -10, which is 4 again. And -2 minus -6, which is 4 again. So again, I was doing -10 minus -14, which ends up being plus a positive, which will give me the +4. And that's what I did for each of these. And we notice that the second difference is constant. It's always the same. Therefore, this will be a quadratic. All right, let's go on to the next one. Okay, I have no idea. Oh, there it is. Okay, I was going to say, I have no idea why it's saying mail@google.com in the middle of my paper, but it's gone. So let's look at the next one. So we'll look at the constant differences here. So we'll go -6 minus a -6.75. So remember, we're always doing the second one minus the first one, because whenever we look for a difference, it's always final minus initial, or the final minus the one before it. So 6 minus -6.75, that makes plus a positive. That means there's a difference of 0.75 there. Okay, we do it again here. -5.25 minus -6. So -5.25 minus -6 turns into plus a positive. Oh, it's 0.75 again. -4.5 minus -5.25. That'll give you 0.75 again. And so you should notice that, again, if you do -3.75 minus -4.5, you get 0.75 again. And so there we go. That's the first difference. The first difference is constant. Therefore, this is linear. Okay, let's look at the next set. So here we go. 10 minus 5 is 5. 20 minus 10 is 10. 40 minus 20 is 20. And 80 minus 40 is 40. Okay, so the first ones aren't the same. And some of you will be able to figure out already that 10 minus 5 is 5, 20 minus 10 is 10, 40 minus 20 is 20. So that's not constant either. You could even go to the third row, and I think you would see that it's still not the same. Okay, one thing that you would see, 10 minus 5 is 5, 10 minus 20 is, or sorry, 20 minus 10 is 10. You will see that there is some type of pattern going on, but it's not a constant, right? This one we would expect again to be 5. So yes, there is a pattern, but it's not a constant difference. And so now we're going to look at the constant ratios. So let's look at the constant ratios. So we'll go the second one divided by the first one. So 10 divided by 5, which is 2. So times 2. That was 10 divided by 5. Now we'll look at 20 divided by 10. And 20 divided by 10 is 2. 40 divided by 20 is 2. So you can see, and you might have been able to see this already, that 5 times 2 is 10, times 2 is 20, 20 times 2 is 40, and 40 times 2 is 80, because 80 divided by 40 was also 2. And so we have a constant ratio. Now that's times, it's not a decimal. So yeah, this is a constant ratio, and a constant ratio means exponential. All right, so there you go. We just figured it out. Now, if you plotted these, you would see exactly the same thing. You would see that this one's a straight line. You would see that this one, you would probably see something like this, but you wouldn't see the whole thing. And so it's only by knowing these constant differences that we can tell for sure that it's quadratic and not exponential. This is the pattern of a quadratic, so it's a quadratic. And then the exponential, you would see something like this, which would end up being too sharp to be a quadratic, but still, that does look like the second half of quadratic. So there you go. Graphing's nice. Knowing the constant differences and constant ratios is better. Good luck on your homework.